This is 7.2.3. We're going to take a look at end behavior. So we're going to find the end behavior of a rational function. Now, end behavior can be describing our graph even further. Now, we kind of talked about end behavior a little bit when it came to polynomials, but when it comes to rationals, there's something very unique about the end behavior because it actually can go to infinity in more than one capacity. And so a lot of interesting things happen. So going back to our example here, we know that our graph is going to infinity now in 4 directions. So with the regular polynomial, it just went to infinity in 2 directions. But in this instance, it's going to infinity in 4 directions. It's going to infinity here because it's going forever this way. It's going forever infinity here. It's going up. It's going forever to infinity here. It's going down forever. And it's going to infinity here. It's going to the right forever. And so we can describe that process. So not only do we have my x is going to negative infinity and x is going to positive infinity, so it's going to negative infinity and it's going to positive infinity, I can actually state what my y is doing. And so as x goes to negative infinity, my y is leveling out to that horizontal asymptote, which is 2. When it's going to positive infinity, it's leveling out to that horizontal asymptote, which my y is 2. So I can describe it that way. Now, what's going on here? Because we have this value of -1, but it's going up in this direction and it's going down in that direction. So there's a special way for us to describe it. And what we do is we tell us what side it's approaching from. So we use this little superscript negative and this superscript positive to indicate it's approaching from the negative or if it's approaching from the positive. So I have it here. If you're coming from the negative x-axis, that's approaching from the negative. If you're coming from the positive x-axis, that's approaching from the positive direction. And so this is where we would use that negative symbol and where we would use that positive symbol. So then going back to describing the end behavior, we know that this is -1, but it's coming from the negative direction. And so coming from the negative direction, what is my y doing? It's going up forever to positive infinity. And then likewise, approaching from the positive direction, what is my graph doing? It's going down forever. So negative infinity. So notice we were approaching -1, but we came from different directions. We came from the negative direction and we came from the positive direction. So here we go. Describe the end behavior of the graph. So if you graph using a graphing utility, I just took the x plus 5 over x plus 2. Now we can start writing what my x is doing. So here's my asymptotes. We have one right here. This looks like it's at -2. And then we have here, looks like y is +1. So my x is doing 4 things. It's going to negative infinity. And then it's going towards this -2 from the negative direction. And then it's approaching this -2 from the positive direction. And then it's going to positive infinity. This is kind of like going in order. Okay, so to say that again, my x value is going to negative infinity. Then it's approaching -2 from the negative direction. It's approaching -2 from the positive direction. And then it's going to infinity. So now I just need to state what my y is or what my y is doing. And so in this instance, as it's going to negative infinity, my y value is 1. As it's approaching -2, my y value is negative infinity. As it's approaching -2 from the positive, that's going to be positive infinity. And then as it's approaching, again, 1 or infinity, it's going to be 1. Now this is an example. I want you to get it down. So this is example. Let's look at another one. So again, it's kind of like weird looking, right? We're like, oh man, look at this rational function. It's doing all these weird things. Okay, here are the asymptotes. I drew them in. So we have -1 and +3 for the vertical asymptotes. And again, we have 1 for the horizontal asymptote. So let's state what my x is doing. So my x is approaching -infinity. Let's move along. Now it's approaching that -1 from the negative. Then it approaches -1 from the positive. Then it approaches +3 from the negative. Then it approaches +3 from the positive. And then it's going to infinity. And the way that you can count it is, where's my graph going to infinity? How many times? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Great. So I'm describing my end behavior accurately so far. So now I need to state what my y is doing. So my y is going towards here, 1. My y is going to -infinity. My y is going to +infinity. My y is going to -infinity. My y is going to +infinity, and my y is going to 1. So just to showing that it's factored, there are my asymptotes. Again, we're going to have these 4 end behaviors. We have x is approaching -infinity, -2 from the negative, -2 from the positive, 0 from the negative, 0 from the positive, and then we have our +infinity. So what is my y doing? It's going to 1, it's going to -infinity, it's going to +infinity, it's going to -infinity, it's going to +infinity, and it's approaching 1. So what did we learn today? We talked about the end behavior of a rational function, and the way that we need to examine it is, where is my graph going to infinity on the graph? Then I can describe it, like what are the x values, and then I can associate with the y values. And just remember, when some of the infinities go, when we have something like this, right, and it's doing this, we have to approach it from the negative, and we have to approach it from the positive side. This does conclude our lesson. If you have any other questions, please leave them in the comments.